Hello and welcome to CIC Start Online seminar and webinar here at Glasgow Caledonian University. My name is Branka Dimitrijevic and I will moderate today's event. Our webinars disseminate outcomes of feasibility studies and academic consultancies undertaken by Scottish universities and small to medium-sized enterprises. Their studies focus on innovations for sustainable building design and refurbishment. The project is funded by European Regional Development Fund and CIC program of Scottish Government. Before we start, I would like to draw your attention to our online knowledge base. During 2011, we published video recordings of 12 webinars. We also published 23 recordings of conferences and 9 issues of Innovation Review, our quarterly online magazine. To enable you to find easily the outputs of our project, we have developed a knowledge base, and you can search for any article or video recording in its sections such as decision making, planning, design, construction, post-occupancy evaluation or performance, and refurbishment. Before introducing the speaker, just a few management points. As this is a live event, it could happen that we have a fire alarm or power cut, which happened at the webinar in October. If that happens, we will have to stop, but we will continue later. If you can join us, that is fine, but if not, a video recording of this webinar will be published later. We plan to finish the presentation around 1:30, and then questions and answer session will start. Online viewers can use a chat facility to ask questions, and you can start using that facility immediately. The webinar will close at 2 o'clock. If any questions were not answered, they will be answered by email by our speaker. So today's webinar title is Insulation of Masonry and Lath Walls in Existing Domestic Scottish Construction. This was a feasibility study undertaken by Robert Gordon University and Craigie Levie, a Scottish company. Our speaker today is Dr. Amar Bennadji of Robert Gordon University, and I ask Amar to start his presentation. Thank you.
Hi everyone, my name is Amar Bennadji from the Robert Gordon University in Aberdeen. We have 2 universities in Aberdeen. We have the Robert Gordon University and Aberdeen University, just to avoid any confusion. To start with, I would like to thank CIC Start Construction Improvement Club. I would like to start to thank as well Dr. Branka Dimitrijevic, David O'Neill and Craig Bishops for their support. Also, I would like to thank the ERDF, the European and Regional Development Funding, as well as the Scottish Government. Today I'm with my 2 colleagues, Craigie Levie, who is the SME partner in the project, and Mike Twiggs, the company who take a large part in the installation of, in the trial that we are taking took place last summer. I would like also to thank my colleagues in RGU, because it's not just a small project. We are in continuous discussion and improvement of the method. I would like to thank Rod, Mike, Bruce Taylor and Bruce Newlands, Richard, David and so on. The project, we gave it the title of Installation of Masonry and Lath Walls in Existing Domestic Scottish Constructions, and we were more concentrating on historic building in north of Scotland and where the trial took place. I'm glad that the previous presentation that took place in, I think, 20th of November by Dr. Julio Bros Williams and Cameron Purdy spoke about the historic buildings and what are the problems and how to improve them. So they saved me a lot of time, and I will go ahead straight away to the topic of today. So then the aim of the feasibility study is to insulate the insulation of masonry and lath plaster wall in existing buildings. And this is, and I stress on this, that while maintaining the original architectural features of this building. The grant was a second application, as the first one was rejected due to the harm that the first proposal might cause to the historic building. We updated the application and we suggested a new method, and this was finally granted last year. The project has 6 phases. The first one was building, the selection of a building. We have had many buildings in a list, and I was with Craigie going from a site to another, holding a bunch of keys with us and visiting many buildings. Unfortunately, many didn't respond to our requirements, which are having an old building that has lath plaster, and it should be inhabited building, because this is important for the monitoring process. Otherwise, it won't work. The second phase, once we found the suitable building, we surveyed the site, and then phase 3 was the testing method and preparation, which was a lengthy stage. Stage 4 was site preparation, and then the application of the trial, the insulation application, and then the remedial work. The team was quite huge. We started with a small team, and we ended up with a quite large team. There was myself and Dr. Mohammed Abdulwahab from Heriot Watt, who was looking for the skills required for such application. And then we had the local architect, Craigie Levie, and David Schumann, who was local architect. Craigie Levie was the SME, and David Schumann, the historic, specialized architect in historic buildings. And then we have the industrial team and an assistant. So it's 13 members. You have the screen in front of you instead of giving all names. And so there are 13 people plus the owners, David and Lisa Gibbons-Wood, who own the place, and they are colleagues in RGU. And I would like to thank them for having accepting to offer their house for this trial. I hope they are online. And so the first stage was looking for a suitable building, and as I said, this was quite difficult to find the right building. And then once we found the Bangodolo house, which is the name of the house, we needed to go through ethical check, and you know, we are using a building. I would like to be clear with the owner as well as with the partners in the project. This is the building. This is one elevation of the building. It's a building of the late 17th century, so nearly 1800. It's located in northeast of Scotland, around Lawrence Kirk area. This is the simple layout of the house. We have the we have the ground floor, which consists of a living room here and a kitchen, and then in the back there is a garage, and then on the first floor, so going up here, the first floor we have a bedroom for the 2 kids, and then we have a room in the back, and this is the room in the corner where the trial took part. In the beginning, we thought to insulate this room, but since it's not used room, we prefer to do this one. And the walls that were insulated are the external walls, so these 2 walls. Just a view of the cavity. We managed to have a very tiny camera to go through the wall. We filmed internally, so the survey was also inside the wall. And we found out that the wall is not, of course, due to it's a historic building, so the wall was not straight, and we have kind of a curve in the wall. And you have, as you can see here, so this is the wall, and then we have the peg, and then this is the last plaster bit here, and this is a curve. I'll see a combined picture. Okay, so this picture was taken, the camera was about this location here, and you see the curve here starting from there. So the decision, which is the decision of the method, was quite a lengthy process, and we were a team. There was a team in Canada because ICNIN company is based in Canada, and they have a representative in Scotland and the UK. KDL is the official representative in Scotland. So we were in discussion of the process with the rest of the team, and in the beginning they told me that we have to drill the wall at specific locations to be able to inject the foam inside the wall, the ICNIN foam. But since our first concern was that we insulate the wall without any damage, we needed to think about the process to do that. And it was email, exchange of email, development of an idea, and then KDL did a trial in their workshop to see how it works. And finally, when we arrived to the site, there was still a development of a method. We still found the problem on site, and we discussed it together, and we found a solution to it. Sometimes on the spot, sometimes we need to shop for something. You will see our experience, interesting experience later on. So this is a KDL workshop where they tried to recreate the wall. So this is not a real wall, it's a creation workshop. And this is to check the pressure that will check all the problems. And I think Mike can explain this later on. But this is the lath plaster wall, but not the real one. And they try to test the solution that the team came up with and see if it works, and how if there are problems, we sorted them out during this discussion period. When they removed the presumed lath plaster, this is what they found. And this is kind of satisfactory to see the middle one. This is what we are looking for, a complete filled cavity, and without harm and without movement of the real plaster, lath plaster. Yeah, we needed also to make sure that, because there are problems that might happen in this situation, and we have here at your left the wall as it is at the moment. We have sandstone, and we have the inner lath plaster and the whole structure. This is how it is, and we wanted to avoid the problem that might happen due to the pressure of the foam. Although the foam expand slowly, there is still a pressure, and because the walls are about 200 years old, the connection between the wall and the timber might be weak due to the movement that the building had, due to the expansion of due to the moisture through 200 years. We might be in a situation where the lath plaster moved from due to the pressure. This is the simplest scenario, and we might be also in a very serious scenario where the hole in the wall might come off the wall, and this is really not what we are looking for. And we need to have a method that should be appropriate to preserve the wall and keep it as it is in its original situation. From the videos I saw of the product published by ICNIM, I saw that the product is expandable 100 times, so volume can be 100 times bigger. I thought just to inject from the top the 1%, we just measure, calculate the volume, put 1%, and then leave the product expanding. But people who know the product and have the experience of a similar situation, they said it won't work. And the workshop where the trial took place demonstrated this. So before we went ahead in the trial, we prepared the site. We covered all the historic or semi-historic features. It's not 200 years fireplace, but we protected everything we can protect, including some of the furniture in the middle. And so this is a fireplace, and then we have we cover the radiators. We prepared the loft was not a floored floor, so we needed to have a secure loft to work on, and lighting, because you need to work on the site for. The trial took 3 days, so we needed to have a comfortable and secure site, safe site. Accidentally, we might have found. I mean, these are part of the debris. We found a big quantity of debris in the cavity when we removed the skirting, and the part of the clean was done by David, the owner, who I would say that he took an important part in this trial. Also, we cover the staircase, and here we removed the skirting and then the carpet as well, because the method needed to create a dam under the wall, because the foam starts as a liquid, and if we pour the liquid from the top straight away, it might go into the floor and expand somewhere there. So it's not, to be efficient, we need to seal all the base of the wall and then inject the foam from the top. With an endoscope, we survey each bay that we're going to work on, and to make sure that everything will work as we expected. A view of some of the surprise, the pipes, the cables, electricity, and so on. And this is exactly the lath plaster, how it looks like from the bottom, where we removed the skirting. It's the only thing that was removed because it doesn't have an historic value in this, and it can be replaced. I will show in details the process, but this you can see here threads. They were slided down from the loft, and pipes were tied to this threads to be able to, when we pour the foam from the top, so we have the gun and then we have the pipes going down, we'll be able to start from the bottom I will see an animation, or show an animation, and we inject some foam, and then the cable will be able to measure how many centimeters it went up. So the foam was injected step by step with a very small quantity, as you will be able to see now. So these pipes where the foam will go down was tied to the thread here and pulled up, and then the injection will start from the top through the pipes here that might be just about 50 centimeters in the beginning or 30, and then go up step by step. Of course, the preparation of the foam need to be accurate, and this is outside the house where the van containing the machine, the containers of the product was outside, and then once the product is tested, they take a sample, they measure the density, and check if the mix is correct, and then we start doing the injection properly. It's, I mean, the instrument out of big investment, and I was amazed about the machinery and all the engine needed to be in the trial or other project, because they are doing also other projects in Scotland. Beforehand, I talked to the owner. This is David Gibbons-Wood. To make things clear for him, we made a model and we discussed the model with him. I let Craig go to the video. Thank you. This is a model, physical model of the wall. So we have the wall and we have the structure of the lath plaster and the foam injected. The video took place, the filming took place in Dobbergod University in the research unit.
I guess motivation links primarily to the need to save energy. Energy costs money. We previously heated the house with an oil-fired boiler. During the winter months, we were using a great deal of oil, finding it to be very expensive. And one of the things that we've sought to do is move away from oil and move into heating the house with wood instead.
So this is the stone wall, and then we have the structure to hold the plaster, lath plaster. So we have the lath here, the plaster here, and bottom there, and this is the system to fix the wall to the plaster. How we're going to proceed to insulate the wall of your house is by injecting the insulation from above, from above. So the first idea was to inject it from different parts, but as you know, this will damage the wall. But for this case, to avoid any damage to the wall, we're going to inject the product from the top by using pipes, where we're going to insulate or inject a little bit of product step by step, so it will be few seconds, and then when the foam spread up, it will go up, and then you go to the third one, and then we leave one and go to the one, and then we come back to the first one, the second one, and then the third one, and then we do it step by step. Is that clear as a process?
Yes, reasonably clear. It seems that I take it that to some extent the foam can run behind these pieces of wood here and sort of spread out along the way.
Indeed. So that's very pointed out. we can control the rate of the foam using infrared camera, and we will be able to know, because the foam is quite warm, we will be able to know where the product is. And then step by step until the wall is fixed. Is that clear, and you're happy with that?
Yes, seems to be a process.
And we need to let you know from the start that there will be a risk, because in the connection between the wall and the plaster, there is this small piece of wood that are kind of nailed, but in wood. And because the house is about 200 years old, there is a risk of the plaster come off. But we try to do it very carefully to avoid that, because we might be in a position that the whole wall won't have. In this occasion, we won't support the wall, because we would like to try it and see what's the pressure that the wall can support. Again, are you happy with this risk?
Well, it's an experimental process. So to some extent, there is a risk involved, but the bigger risk is that if we don't do this, we would have to remove all the old lath and plaster to put the board behind, and that's a far bigger risk to the wall. So in effect, this is minimizing disruption, and it keeps the old wall there, and that's associated with moldings at the side and a picture rail at the top.
Good.
So this is it seems a relatively simple procedure, if you like, in comparison to taking off the whole wall. Because some houses I've seen people take the wall off, but for just small patches of wall, and the amount of waste that comes off the wall is huge. So hopefully this will be.
I'm happy about your answer, and you are positive.
Hello, I'm Jeff Hood. I'm Vice President of International Sales for CIC, and I'm one of the owners of the company as well.
Finlay Black, Complex Manager with KDL, and just along here really just to give an extra set of eyes and ears to see how the process works for the future.
I'm Craigie Levie. I'm the lead architect on the project.
Rob Gilmore, the Technical Services Manager at IC from Canada.
Okay, and your role in this project, please?
Is to work with the installers on setting up the product properly.
Add the insulation, which replaces the 40 mils of cavity. It gives us a U value of 0.54. So that's a huge improvement from 1 to 0.54.
Being is the spray foam cures within about 6 to 10 seconds. And expands 100 times its initial volume in that time. And the core foam cures slightly more slowly. I think they're seeing the same expansion for over a 3 or 4 minute period.
So it's much less
exactly, it's just a much gentler process.
And you can see exactly what happens, which is that they're hammered in by a joiner, and over the years they rot slightly, or very often we heat houses more than they used to.
Yes.
And they're much drier.
Yes.
And so that they shrink, and the walls then become unstable.
Yes.
And the combs on the back, because there's some movement, as the Duke's loosened, the combs fall off, and they fall down, which is what all this debris is, and then that makes a path for moisture to come through the wall.
And since they are loose, is there any danger that the whole wall come off due to the pressure of the foam?
That's
The
what we're find out.
This is, I mean,
there's a danger if there's too much material put in, and there's too much left to expand. Then yes, there's a danger to push it out. The skill's really to make sure that it's only put in small quantities, and it's got room to expand.
Yeah.
As long as it's careful. Yes.
I mean, one of the things that we have discussed is the possibility that in particularly taller walls, maybe listed buildings where the internal fabric is particularly precious, that we may have to slightly brace the wall. I don't know.
I think that's not
for historic building, I mean, castles where the walls are quite tall, maybe this may be the procedure.
One of the key advantages to this product that we we've hoped for is that there's going to be a degree of stabilising that bind it together, binds together.
But there isn't a way to maybe, because calculate the volume of sort of the cavity and then have an estimate of what needs to go in to avoid rather than. So probably, I'm sure there must be some sort of.
Yeah, I mean, we can certainly work out, have a good idea what the volume of the cavity is going to be, or what it is.
So this is the dam creation in the beginning, the bottom of the wall, and then how the foam expands and creates a barrier for the foam to don't go down the floor. And this is a view from the loft, how the foam is injected. Okay, so I would like to remind that although it's a trial took part in 2 walls of a house, here in this trial we are celebrating the whole architecture history of buildings, the historic buildings in Scotland and in other places, and the method can be applicable for other buildings elsewhere. So we are celebrating the history and not just a trial, but this should be a key for the future. Okay, so this is a schematic drawing from the wall, and I'll show how step by step we tried few things to see how it works. In the beginning, the cable went down as we saw before, and this happened in each bay. We attached the pipes to the cable, the thread there, and we did in the beginning a trial of 10 seconds. So the guy was injected on the top. He counted, I don't know if you had that, until 3 or 5 at this point. But in the beginning, we tried 10 seconds. So we inject the foam for 10 seconds. And we kind of have a feeling if the wall will resist to this or not. And then we leave one empty because the foam might go to because there is a space between the studs and the wall, and the foam might go to the other bay. So better that we leave one and we do another one, and then we come back to the original one. So the next one was 7 seconds, and with the infrared camera we can see how the foam expands and how it goes to the other side. And then we went for if you see the wall during the trial, you can see that there are many descriptions that 10 seconds, 5 seconds, 3 seconds, until these are the first trial. And then we decided after that to do 3 seconds and 5 seconds, depend, to complete the whole installation. So the next step was 5 seconds in the middle, as you can see in the screen. And then we carried on doing the 5 seconds injection. And as you can see, the foam is expanding from place to another. And then we move to the third, the fourth one, the fifth one. And we pull up the pipe, and then we inject the foam. And as you can see here, that the foam sometimes doesn't stick between the 2 steps, but it goes beyond that. And with the infrared camera, you can see what's happened there. And so when we pull the foam, we try to be more closer to the gap there instead of being there, just to avoid that the foam expand in the middle here and leave a gap there. So there was connection between people who are working in the loft and people who are working in the room. And then the infrared camera, and then measuring the distance, and then sticking timing for each injection. It's a good coordination, and I should say that it was a great experience with the team, and I didn't, okay, I was kind of looking after I was not managing, and I didn't need to use any stick. It was kind of everyone knows what to do, and there was good harmony in the team, which was, I think everyone appreciated this. So this is the step one by one, until I do this just a bit quickly to see how things happen. So yeah, we until this happened. So we use in the beginning a specific type of pipe where the foam doesn't stick to it, and so there is no blockage. And at a certain point, we realized that we ran off pipes and we needed more. So Craigie and someone else went about 40 miles away to buy other local pipes. And when we tried it, this is what you can see, the foam after first injection sticks inside, and it was really problematic. And we discussed the solution to face this problem, and we decided that after each injection we inject the air alone. This is to liberate the pipe for the next injection. So the reaction of the foam the pipe need to be with the right pipe. So as you can see, we have blue and white pipes, and each one reacts in different way in the rest of the wall. So this is another part of another wall, but you understand the scenario until the completion of the whole wall. And as you can see that this is just a sketch, but we can find an area where the foam went beyond the studs and not in other places. And this is because of the nature of the wall. The wall, as I said, is not a straight wall. There is movement in it. There is sometimes a gap, sometimes not, between the wall and the timber structure inside. This was monitored with the infrared camera. So in the room, when we inject, you can see that the injection happened there, that the higher temperature is there, and then when the foam expands, it loses its temperature. The foam is injected at a point, and then we can kind of draw an area where the foam filled. So it was here, and then you can see that there's a passage there, and the foam expanded here as well. And this is the dot is the end of the pipe. When you pull it up, there's a bit of. So we have a lot of screenshots of this infrared monitoring process. One of the final views of the foam seen from the loft. So once the wall is totally filled, this is the end of it. So we are in the loft, and this is the front elevation from. Okay, so this is the final expansion of the foam on the top, and in some areas like under the windowsill, we found so it's not the same. It's not lath plaster. I think they use another. We just decided to insulate this area because it will be a very big thermal bridge. As you can see, the wall after the completion, we have in the bottom the foam, the dam, as I call it, and you can see that we have a skiption of 7 seconds and then 7 seconds there while we're moving up in the wall. Okay, it was during the trial itself in the house. We spent 3 days, and I think the team deserved from time to time a coffee break. We were 15, but I think many of them are here, including the house owners. Everyone is smiling and enjoying the experience with nice coffee and cake and juice. Some material specification was recorded with the technical team, and I leave the video running, please. Is there any organic material or purely chemical, or how green is it?
How green is it? Well, once the product's mixed together, it's basically chemically inert. It's non-toxic.
Okay.
You can eat it if you want to. It's not toxic at all.
Okay.
It's not dangerous for landfill or anything like that. So it's totally inert.
One of the big benefits, one of its green credentials, is the fact that we basically take the material to the site and produce the insulation on the site. We're not making boards of insulation that then are going to be transported around the country. So we can carry a lot of insulation in a small vehicle that's using a lot less fuel to get there.
So this is the green part of
that makes it very, very green.
Yeah.
To get enough insulation to do a building, usually you'd have a couple of wagons on the road, basically transporting it to the site. We can get that. We can carry enough material in there to do possibly 2 houses.
Okay.
And then if we wanted more material, it's just a matter of putting some more on a small trailer and taking it to the job.
Ultraviolet is the one thing that will cause our product to degrade and return back to elemental carbon over time.
If there is debris in the middle, do you think that the string will be enough to make sure that there is liquid?
No, the string is here just purely to be able to pull the pipes down from the top. We've already had fiberglass probe down the back of the wall, and that's how we get the string down. There's an open void from top to bottom.
Good.
Yeah. And we'll repeat that process.
So you don't need to manipulate a little bit to evacuate any debris.
No, well, it appears not. No. We'll carry on and do it between each set of timber battlements, just to check it.
Yeah. We couldn't see the light. Yeah. Maybe the wall is curved. That could be. It could be curved. So.
The light.
Take advantage of any opportunities that there are to introduce the product via speaking engagements to architects, and also working with the university on a program like this. I think it's perfect because our product, being relatively new to the marketplace, needs a third party like an academic to verify that the claims that we're making are valid. And we feel, based on the 25 years and 15 million tons of CO2 that we've prevented from going into the atmosphere, that we have an ideal product. And so it's just a matter of time to introduce it to the marketplace and gain acceptance.
Okay. Jeff, thank you and welcome to Scotland.
Thank you very much.
Yeah, thank you, Jeff. Just to feel the product, it's quite a very light product. During because we know that we will need to monitor what's going on in the cavity, and this is to avoid many questions that I already see in the screen. One of the way to monitor, we put in the cavity itself sensors that allow us to monitor the humidity and the temperature, as well as now the second phase of the project is ongoing, to really know, which is the scope that everyone is waiting for, what's going on in the cavity wall, and is the product really efficient for historic buildings. So this will be a go-ahead if we have positive results. So this was we decided to take in the beginning two sensors to really see. This is a coin of 10p, which is about centimeters and a half, and these are the data loggers. This thickness represents the cavity wall, and we decided to put one sensor just at the external contact between the external wall and the foam, and the other one in the contact between the lath plaster and the foam. We went to the minimal cavity wall distance. So these are the two loggers, and these are to support them. So once we pour the foam inside, this will be covered with will be in the foam, and then with cables we can read the data from with USB cable. And because it was very narrow, sometimes just 1 centimeter, sometimes 2 centimeters, sometimes wider. This is about the cavity. We decided just to put one because there is no sense to have two, because they touch each other and it doesn't really make sense. As well as other way of monitoring what's going on in the wall, and this will take place in future webinar. So the next step is to monitor the building. So we have sensors inside, outside, and in the loft, in the kitchen, in the corridor, and we are waiting to be able to read exactly what's going on through the history of the trial. I think the trial was successful since the aim of the trial was to maintain the originality of the building, to keep the building as it is without any, so that is, as you can see, the building, the wall, the inner walls are very clean, and there is no holes there. So this is the objective of this feasibility study, and I mean, we published this somewhere, so there was a few papers around. Some of them I know about, some of them are surprise. And this is part of the team in front of one of the trucks who were on site. Even the kids, so we are preserving these buildings for these kids who I think will recognize that will enjoy the historic buildings in future if we manage to maintain them, and also to reply to the national and international agenda about keeping the CO2 emission down. And this is one drop in the ocean, and we hope to carry on studies looking at various aspects of energy conservation, including the sash windows, the floor insulation. Sometimes we have floor that we cannot insulate, we cannot under insulate, and found a solution to do that. I would like to thank again the audience online, and if you have any question, please come forward by email, and we can discuss other things as well. I would like to invite my colleagues to. Thank you very much, Branka.
Thank you very much, Amar. Yes, I would like now to invite your colleagues who worked on this project also, Craigie Levie and Mike Tweets, to join at the top table, and we will start with the questions. There are already many questions online, and I will go through them one by one, and we will first answer them. The first question is from Robert Banham, who says, did you consider what the impacts would be of only undertaking partial insulation of the property?
Yeah, okay, it would be nice if we insulate the whole house, but since it was to try and insulate the wall without damaging the inner wall, doing it in one wall might be enough, but we did it for 2 walls. So the trial was to make sure that there won't be any damage. I know that for perfect insulation, it's better that you do the whole house and the ceiling, the floor, and then improve the window and so on. We are in the start, and we hope to, with the team, to do more of that.
And the damage wasn't simply sort of physical damage due to the installation, but also we still don't know at this stage what the long-term implications are, and especially how moisture in the wall will behave. So I think until we know that, after probably at least a couple of winters,
Indeed,
I don't think the owner was desperately keen on risking its entire building fabric.
Okay, thank you very much. The next question again from Robert Barnham. How realistic would this application be in properties more intensively occupied and in buildings with multiple ownership? I'm thinking of stone-built tenements. 25% of Edinburgh's housing is pre-1919 stone-walled tenements. Who would like to answer?
I think it's about management in this case, and there is a legal aspect behind it if there is multi-ownership, and in terms of application, it's about management. How we can do wall by wall. We can relocate flat by owners of or occupiers of a flat by flat. I think it's a very serious question and interesting, and yeah, I think it's about management.
I think, I think the trial shows fairly clearly that was one upstairs room. You could think of that as one flat in a tenement. Where things get complicated, I suppose, then if there is an issue around reducing air movement in the wall and any subsequent problems, if one flat is responsible for that, potentially there's a liability. So until we establish that issue.
Okay, thank you very much. The next question from Erin White. Does the foam retain moisture that could potentially be damaging to surrounding historic material?
The material is an open cell, and it doesn't catch the moisture, and this is why we used it. Comparing to other methods where you have to leave the gap and then put insulation, if there is no, I think it's I think, I don't know if I said that, but it's an open cell. I didn't go to the description of the material, but it's an open cell foam, so it doesn't retain the moisture.
I don't know, Mike, if you can expand a bit on the nature of the material.
It is. It's a fully open cell. It's a hydrophobic material, so it doesn't actually attract water. It won't wick water. It won't soak water up in any way. So yes, as Craigie's demonstrating there, it's not actually taking the water on.
Can you squeeze it? Can you squeeze it to see if there is any water in there?
Very, very little. I hadn't tried that before.
I mean, the beauty about it being fully open cell, that if it's fully immersed in water, it will take some water on. But then once the water level drops away, it will then fully drain out again. Apparently, one of the benefits in flooded areas are buildings that get flooded are allowed to dry out, and the insulation returns all its properties back to the same as they are when it's new.
It's a rather odd material. If you take a piece up to your mouth, you can pull air through it, and yet it won't take in water if I dunk it.
It doesn't wick water up. It won't actually soak water up, no.
The next question is from Eloise Wood. Was this building listed, and if so, was the conservation officer happy with this approach?
It's a listed building, B listed building. So the lath plus is not part of the. So we tried it because it represents what can be in listed all the listed buildings, but the inner wall was not listed, so it was fine.
Okay. A question from Jim Sutherland. Surely this flies in the face of all conventional advice regarding ventilation of roof spaces and cavities.
Yes. And as I say, this is certainly from my point of view, the most interesting thing is the next stage to see how this behaves. But in new build, for example, we seldom use cavities anymore. If possible, we'll fully fill roof constructions and so on. Certainly my experience in renovations and alterations to even quite recent buildings is that previously where we'd left, for example, 50mm cavities in roofs, very often these simply aren't working. And in fact, I think there may even be an argument that you're allowing moist air into a building, that if you can reduce that air movement, you perhaps improve things. But as I say, for me, that's going to be the most important part of the next stage.
Here is a question, related question, obviously, from Robert Barnham. A question about air movement and moisture. The view of the insulated gap at roof level shows the insulation sealing the anti-space to the sacking boards to the roof. Were there any residual damp issues in the stonework walls, and were any measures undertaken to retain air movement in the loft area to otherwise address the issue of condensation on the roof of the roof timber?
I'm thinking of the loft construction on this particular one. Nothing particularly has changed there. It's as far as I'm aware, the roof construction is Scotch slate on open boards. There's no felt. There's lots of air movement in that area, so nothing particularly changes. As far as this behaves in a roof timber, I think Mike, you would.
Well, I mean, it's been tested by the BBA to say that it's perfectly fine to spray it straight onto the back of sacking boards in any timber roof situation, even if there's breathable or non-breathable roof belts underneath the slates. So that's been fully tested by the BBA to show that it's not causing any problems at all.
The next question is from Jerry McWigan. If it does cause a problem and damp walls, how do you get it out?
It's one of the beauties about the foam injected behind the lath and plaster is that it fully fills every void. It sticks to everything, but you can get it in there without doing any damage to the wall. If you were going to put any other form of insulation in there, you'd have to start taking the lath and plaster off. Unfortunately, if there was some reason it wanted to be taken out in the future, then the only way to get it out would be to take the lath and plaster off and remove it. So there's not really any other way of doing that, unfortunately, because of the properties you get in by injecting it in the first place.
And that's why the building that was selected is not, the lath plaster was not listed in this building. So in case, because we are monitoring and would like to have a positive output, if this happened, so this would be the case. So so far the wall was not damaged, and we hope to have positive answer.
I mean, that goes back to the earlier question as to why we only insulated part of the building.
Okay. Here is a question from Dipaniti Das. What is the lifespan of this product?
Isonine's been making this product for over 25 years and using it in Canada and North America. So we know it's certainly got a lifespan of over 25 years. They've tested some of the material that was used in the very early days, and it's still displaying the same properties as the material that we're putting in today. So the lifespan certainly seems to be well over 25 years, probably indefinitely.
That was very much one of the attractions of this material when Amar and I first discussed what various options of fibres, blown fibres, that kind of thing. Again, from experience of taking down these types of construction, very often there's a lot of slump. There's materials which are reduced in effectiveness if there's any damp, and this seemed to be something that once it's in place, because it sticks to everything, it tends to keep doing what it's meant to almost indefinitely.
Mm-hmm. And since it doesn't touch doesn't see the ultraviolet, the product one, it's biodegradable, so it can stay as long as, we don't know how long, but if you want to have rid of it, it's biodegradable, so just see the ultraviolet and it will be degradable. Other companies can use it to recycle it for packaging and for things like that. If we want to remove it or there is a spare like that, it can be reused in other parts. It's recyclable.
It also reduces down to, and I think you demonstrated turning it into a thing like a credit card. It flattens down to next to nothing.
I mean, basically, it's 99% fresh air. So if you've got a very small quantity actually going into any construction, the actual dense material at the end of the day, once it's been squashed out, there's very little of it.
And it's not a memory foam, so it doesn't come back to its initial shape. So don't use it for mattresses.
I mean, one of the things that we'd hoped from the foam was that it might, to a certain extent, stabilise historic structures where the timber dukes have shrunk and the timber structure is starting to become detached from the masonry. This might go some way towards sticking things together. And I don't know if it's got enormous structural properties, but generally, if you can prevent any movement, then you don't get this continual breaking of the combs on the back of the plaster, which also then cause a problem by filling cavities and creating cold bridges and paths for moisture.
I can recall that the owner, David Gibbons-Wood, after the trial, he felt the wall with hand and said, I feel it quite rigid. So I think this is, I don't know if psychological, but it's what happened.
Okay. Here is a question from Harry Phillips. How do you know that the foam filled the cavity as illustrated in your diagram? That was probably asked early at your presentation because you monitored, obviously, but you can explain a bit more.
Yeah, I mean, we changed the time from 10 seconds to 5 to first of all to avoid the movement of the wall, and secondly to really monitor properly the foam expansion. With the infrared camera, we can know where the foam travels, but I cannot say 100% that the wall is totally filled. We did our best, and I think we monitor it properly. We do it step by step. We are very careful. We took our time. So you are right. I don't have 100% answer that the whole wall was filled totally.
No, we obviously can't see behind the wall, and we don't drill any holes to find out where it's going. We're very careful where we put it. We make sure it goes in very small quantities, and we're methodical of where it goes. When the reaction of the foam expanding, it is giving off heat. That's how the thermal imaging camera can actually pick up the signature on the wall of where it's going, where it's expanding to. So that gives us a very good idea where it is expanding to. As Amar pointed out, there could possibly be small pockets where it hasn't expanded. If there's something for some reason blocking the expansion, then yeah, we can't be 100% sure absolutely everywhere it's filled.
Despite that, we had the endoscope and a very tiny camcorder to go inside the wall from the top, but it was not possible to. With the steam of the foam and its react, everything we cannot see properly.
Okay.
Thank you for the question.
The next question is from Colin Davidson. How is the heat built up in the cavity assessed to ensure that thermal images taken during application represent an accurate reflection of the extent of foam filling within the cavity?
Good question. The product, when it reacts together, the two products, when they react together, they get to the temperature between 140 to 160 degrees Celsius. And of course, when it expands, it cools down. But until the last bit expands, there is still a bit of heat there. And when we draw we are monitoring and then drawing where is the product. It gives us, again, not 100% an accurate reading, but you can guess that because this is hot here, that means the product has expanded until there. Yeah, so from 140, 60 degrees to goes down to before it becomes the ambient temperature, the foam has already expanded to the maximum. I don't know if you have another explanation.
Yes, I mean that's basically it. And one of the beauties, one of the reasons as well for not injecting one area of foam directly next to the next area of foam is so that we don't get too many misreadings from heat from one injection then showing up on the next injection. We do one injection in one place and try and do another injection further away so we can get a definite signature of where the heat's actually showing in the wall, as opposed to being one area still drawing heat out of the area that's just been injected.
And to a certain extent, the more of these you do, the more you'll know simply by the amount of material you're using and the relative size of the cavities.
I mean, to monitor it with the thermal imaging cameras, the camera has to be very sensitive and it has to be set to the right temperature range to get the cooling down part of the foam as opposed to the really hot part of the reaction.
Yeah.
Okay. Here are more questions from David Rollins. How does this foam compare with foam insulation sometimes provided to underside of slate roofs? There seems to be significant potential for cold bridging, especially if any debris remains. What impact will the foam have on the breathability of the wall internally and externally to allow moisture to evaporate out through the walls? What is the impact of the foam on any wiring?
Few questions there. If we work from the bottom, there's been tests done in Canada that the foam doesn't affect the insulation of any electrical wiring in any way. The one thing that we've got to point out, especially in retrofit, that any electrical cables completely embedded in any insulation, it's advisable that the wiring's checked to make sure that the wiring's still up to spec. But the foam itself won't do any damage to the wires at all. No. What else have we got?
Breathability?
Again, with it being an open cell structure, structured foam, it has full breathability. It won't trap moisture in any way, and it'll still let any moisture, any dampness in the timbers dry out. So therefore, it's not trapping any moisture in, and it won't cause any rot.
And the debris?
I mean, the debris behind the wall, the debris between the lath and plaster and the masonry, I think you mentioned it as a cold bridge. Really, more the worry there, other than cold bridging, is there actually could be a moisture bridge between the outside skin and the inside skin. That's one of the reasons that we take quite a bit of time to try and check that the cavity behind the lath and plaster is clear. To do that, we put fiberglass probe down and basically rattle it around to make sure there's no blockages in there. And then we're putting an endoscope down again to make sure everywhere is clear.
And I mean, if you have seen the video, when I asked the pipe, when I took the pipe down, I suggest also to move the pipe right and left to make sure that at least we have this 1 centimeter of the pipe going right and left to make sure that there's no debris left. I mean, these are developed on site, so it's.
There is also.
Yes, we also blew a jet of air down there as well. We rattled an airline, dropped an airline down the back as well, and that's dislodged any small debris and let it fall down to the bottom. All the debris is then just hoovered up at the bottom to make sure that everything's kept clean.
It's nice that we have Finley Black on site, so he's adding to the answers.
There was the first question, how does this foam compare with the foam insulation sometimes provided to the underside of slate roofs? What is the U value of this insulation?
Well, the thermal conductivity of the insulation is 0.035. There's quite a few different foam insulations on the market today, and there was quite a bit of bad press maybe 20 years ago with foam insulations that were sprayed straight onto the back of slates with a view of gluing slates back in place if there was nail fatigue and slates were slipping off. That might be what's being referred to there. That material was closed cell. It was a completely closed cell foam, and it was proved to be trapping moisture in the roof timbers and causing rot within the roof. The main difference with this material is that it's not closed cell. It's completely open cell and fully breathable. it will still do the same insulation properties as the old spray foam insulations would do, but won't have the same drawbacks with it.
Thank you very much. Here is a question from David Rollins. Is this method reversible? That's something that probably Historic Scotland will ask.
I think you addressed that.
Yes, I think no, it isn't reversible. It would only be reversible by removing the lath and plasters to get in there and get it out again. One of the benefits of it is that it bonds to everything, giving you a full air seal, a full airtight seal to the building. Anything that's going to do that isn't going to be easy to be removed.
Okay. There is a question now from Keith Pierce. How would you insulate ground floor walls which have no attic space access?
It would have to be considered on a project-to-project basis. I would imagine, as long as there's some access can be taken from the top or from the upstairs floor, if the skirting is going to be taken off on the first floor, you would be able to get access to the ground floor walls there, basically past the first floor and get access down there.
We did discuss this. In fact, the very first method that we talked about involved cutting letterboxes, in effect, at maybe below cornice level, and that was discarded.
It was rejected by.
It could still be used.
Yeah. It can be if the internal fabric isn't particularly precious, then you can drill holes. You can get the material in that way. If you've obviously got to be able to get a 1/4-inch pipe in behind the wall to get the material in there. If there's absolutely no way of getting the pipe in, then you can't get the material in.
It's a case by case. I mean, all houses are different, or buildings are different, or castles are different, and it's not just one method and then it's applicable to any building. There is a difference between one another, and this is what all surveyors, when they come to insulate a wall, even using the traditional method, they assess the building and then they give you a code. So it's because it involves more time, or it has difficult, complex way to get the insulation there, and so it's case by case, as you said.
Okay, we have quite a lot of questions, so let's keep our answers short,
okay.
Because if we want to answer all of them.
Yes or no.
Jim Sutherland is asking, what does Historic Scotland think of your system, if you have advised them or consulted them or had any discussions yet?
Yeah, Dave Schumann, who's a conservation accredited architect, was involved in the early discussions, and he did a great job in sort of keeping us up to speed in research that Historic Scotland is currently carrying out. And I think everybody working in this area is very interested to see how this will go.
Yeah, we had a discussion with Historic Scotland some time ago, and we suggested the same method, not using isonine but using other material. Yeah, they were happy, but we didn't have a project to do. Yeah.
A question from Alice Constance-Baker. What tests were carried out on the insulation material prior to placement in the building? And what is known about its breathability? But the tests as such, any other tests apart from the workshop that you organized on the site?
It wasn't needed to gain breathability information from our workshop trials, and the material is 25 years old. It's been well tested by the manufacturers, and it's been used worldwide in that time.
Here is a question from Adi Roger. I may have missed reference to this point, but there seemed to be no mention of how to deal with chair rails, dados, and picture rails, or horizontal buttons supporting some cornices which block the cavities.
Again, it's a kind of case by case thing. In most constructions, if you have a chair rail or a cornice, there tends not to be a horizontal barrier that fully seals against masonry, so that there's generally some path for the pipes to go. But in the event that you did have a complete seal, then you may have to look at drilling, creating slots, doing some other.
If there's a barrier in the wall that's maybe only a third of the way up the wall. I mean, it's certainly possible to put the pipes up the way once the skirtings have been removed as well, to fill the lower sections of the wall and then fill the top sections, putting the pipes down from the attic. Again, it's on a case-by-case basis. You need to have a void to get the material into for the material to do its job.
I think if in the oil industry they manage to drill vertically and then go down and then horizontally for a certain distance, if this technology exists, so it can be applicable to, and instead of using this pipes, you can use this flexible way to get the material around.
Okay. Another question. Jamie Renton asks, is the product fire retardant?
The product itself won't burn on its own. It needs a flame there to actually keep. It's self-extinguishing. It'll not sustain a fire, but if it's in a burning building, yes, it will burn.
However, there is also the possibility that it acts as a cavity closer and reduces the spider flame to begin with. So potentially it improves the fire resistance of building.
Okay. Question from Erin White. Would the foam need reapplication? And if so, how long before that would be necessary?
I think we answered this.
I think we've already answered that. The foam's been around for 25 years and it's still performing as it did the day it was put in. So reapplication shouldn't be necessary unless there's some significant change to the building.
Okay. A question from Keith Perth. Can you estimate the likely cost for insulating the room undertaken in the pilot study?
There was obviously a lot of, we wouldn't tend to have a 14-man crew that would go and do a building like that. So there was a lot of costs incurred doing the pilot study. And again, the costs of insulating a house really need to be done on a case-by-case basis.
Okay. From Harry Phillips, the worry is that in tenemental situations, adjoining owners' living patterns may generate more moisture in the cavity, which could not be ventilated because foam blocks the vertical path. Any comments on this?
Yeah, I think going back to the ventilation issue, one of the problems that we're trying to address, certainly for surveyors of my clients, if they have an enormous listed structure, in the past the principle, I suppose, was that the building was heated, and that heat meant that you could ventilate behind the internal fabric, and you were continuously pushing heat through the fabric. The cost of energy is such that you simply can't afford to keep chucking that amount of heat in, and therefore the ventilated cavity is simply providing a method of getting cold, potentially moist air to run past a cold internal fabric. So I guess even though there may be problems created by that, perhaps it is just a question of saying, well, let's stop the air movement completely.
I mean, once you go to fully airtight buildings, you've really got to start looking at alternative methods of ventilation as well.
Okay. A question from Peter Porteous. My concerns are, first, material off-gassing over time and what gas is given off. Second, breathability airborne moisture rather than actual water uptake as demonstrated. And the third, partial insulation only. Will this not simply encourage heat loss through the uninsulated parts of the building fabric, i.e. all or nothing would be best?
Well, the off-gassing, the isonine is purely water blown. It only uses water as the blowing agent to create the foam. At 160 degrees centigrade that the foam reaches when it reacts, all the water is then given off as steam straight away. And there's nothing else then left in the little bubbles in the foam other than fresh air. So there's nothing to off-gas, there's no gases to come out. There's no chemicals being put in there to improve the U values in any way. It's just purely fresh air. So the off-gassing is just not an issue. What was the next one?
Breathability airborne moisture rather than actual water uptake.
And again, once you go into airtight buildings, you should really be looking at other ventilation.
The advantage of that is that it allows for the potential of heat recovery. You know, we're certainly finding that on listed buildings, reducing air movement, for example, grass stripping windows and so on, it makes a vast difference. And the questions of whether you're achieving fabulous U values and so on the walls are fairly immaterial while you've got that level of air movement.
From David Rowlins, I think you will find, at least in England and Wales, that the lath and plaster will come under listed building protection. That's a comment on whether internal walls are also...
And here I would suggest in some cases the internal fabric, we might list wallpaper, you know, there's all sorts of features within buildings which may be part of the listing.
It was not the case for this one.
It was not the case with this one. Okay. A question from Alice Custis-Baker. What would your approach be if replastering was required?
After a wall's been treated, if replastering was required, then it would just be plastered in a conventional way. There's, the insulation wouldn't really affect any replastering. I mean, maybe the question means that if the lath and plaster had to be removed and plasterboard was then had to be put on. I mean, again, it would be a little bit more laborious to get the lath and plaster off, but it could be removed and plasterboard added. But if that's the case, then the internal wall finishings obviously aren't that precious anyway.
Okay. Question from Malcolm McKillop. If a wall is insulated and electric cable is totally covered, surrounded in insulation, it is derated by 50% of its current carrying capacity. How would this be accommodated?
I mean, again, as we mentioned before, it won't affect the insulation of the electrical cabling, but the electrical cabling may need to be upgraded in certain circumstances. Again, an electrician should certainly look at it and advise on it.
Okay. We have a quite long comment from Gary McGuigan, which refers to some BRE publications. We will forward this to our speakers to comment on this. But let's go to the next question, which is by Jamie Ranton. What is the projected U value achieved through a typical Scottish wall construction?
It's the U value was after the installation was 0.54 after the installation.
It's still not great, but again, what we hope is that the reduction in air movement makes a huge difference to the heating costs of the building.
I mean, basically, the calculated U value before the insulation was 1, so it was an improvement from 1 down to 0.54.
Okay. A question from Bernd Balf. There is no vapor barrier. Has the risk of moisture from inside the building passing through the wall and condensing on the cold stone be assessed, tested over time?
That's the next part of the project. And again, my gut feeling is that there isn't really a huge change. You've got a material which isn't going to completely stop moisture movement within a construction, and that to a certain extent it might result in a wall which stays warmer longer and then has more tendency to push the moisture to the outside of the fabric.
There is a comment from Robert Burnham. Colin Davidson's question is very relevant. Normally, thermal imaging needs a 10 degrees Celsius differential to give an accurate impression. That's just to note for future. Now, a question from Jeremy Cockcroft. Installation process seems complex and time-consuming, so rather expensive, I expect, especially to do a whole building. Have you calculated a payback time?
I think it's, for this trial it was time-consuming. That's right. We discussed a lot during the trial. That's right. But until it's the application become, I mean, until we develop skills and people will be really skilled to do it straight away, and I think the cost will be down, and at that time we'll be able to really calculate the time return.
A question from John Council. What is the resolution of the camera that you found that you needed to use? If you remember.
No.
A question from Gary Mees. What is the fire resistance classification of the product? If you know classification.
I don't know off the top of my head. I guess if you went to iSigning's website,
yes, I think
they would have a full technical specification.
I mean, again, if you looked at the BBA, which is published on the iSigning's website, it would give you the fire classification on that as well.
A question from Jerry McGuigan. Does it give off toxic fumes when it burns?
When it burns?
Burns.
When it reacts, maybe?
Not that we're aware of, no.
And the people were, when you say burns, maybe he mean or she mean the reaction, the chemical reaction. It's heat, and then it's not. I mean,
what if there is a fire in the house?
Ah, this is about fire.
I think the reactive material, if it burns.
If it's burned, okay.
Yeah.
No answer right now.
I'm afraid I don't fully know what it would give off.
A question from Harry Phillips. I would have expected you to recommend a new vapor-resistant application onto the wall surface, such as a rubberized paint.
Onto the wall surface?
After use.
I mean, actually on the masonry wall, we obviously can't get to it. I mean, in front of the lath and plaster, I don't know.
I think, again, I think what's a safer option is to allow as many of the materials to breathe independently as possible.
Okay, and finally, we have a comment from Eric Wells. Are you familiar with the work done by Dr. Alan Owen of Robert Gordon University using silver pour beads to fill lath and plaster cavities? This would seem to get around problems of flow and fill of cavity as it is by gravity, and still allows a small amount of airflow to remove moisture. It would be interesting to compare achieved U values.
Yeah, Alan Owen is a colleague of mine. He used this method, and I think it's for his own house. Yeah, maybe this is a suggestion that I need to discuss with him. Yeah, then, I mean, we talked a lot about this. I mean, I know about the project he did, and yeah, thank you. Suggestion.
Yeah, there are a couple of things about any kind of bead or fiber that gets blown in that we did discuss at the start, and one of the conclusions was that where there's any level of air movement, actual drafts penetrating as there is in a structure like this, that there's a tendency for beads to migrate. And around about the time that we first looked at this project, I was actually involved in a project where we demolished a building which had retrofit cavity insulation, and over one floor the slump seemed to be as much as 300 millimeters in the 15 years that the material had been in place. So that kind of gives us an idea.
Yeah, and I mean, we agreed to use this product and this method because previously Craigie and his own and myself my own, we assessed all the buildings and we saw damage that causes to granite buildings that have lath and plaster, where people needed to really demolish the whole interior and replace it with a plasterboard, which was very, very sorry for that. So yeah, there is lots of things wrong going out there, and
thanks very much. And final comment from Harry Phillips. The application of a vapor barrier would be onto the surface of the plaster. That's what he was referring to in his previous question. I think we are now really close to 2 o'clock, and it is time to close our event. First of all, I would like to thank our speakers today and online audience for asking questions. We don't have any more time to ask our audience here if they have any questions, but There were so many good, interesting questions that we have received from our online audience. So, our next event will be a whole day, a live conference in Glasgow on 2nd February this year. Its title is Build Tight, Ventilate Right, Air Quality in Housing. This conference will provide landlords, architects, housing associations, developers, policymakers and legislators with important new knowledge that is emerging from current research and practice in the UK and in Europe that examines relationships between ventilation, indoor air quality and health. More information on the talks, speakers, sponsorship and exhibition opportunities and booking is available online on our website. Please also check the list of 8 forthcoming webinars on our website, and you will of course receive information in our e-news and directly personal links